Number 11 on page 2. Let's get started. Which relation represents a function? Place a check mark in the box for all that apply. So we're trying to figure out which of these is a function. So we're going to go through each example and say yes or no. It says that this is an all that apply question. So there could be more than one answer, or there could only be one answer. Now, before we get started, I want to go over what constitutes a function. To be a function, every input has one and only one output. When we talk about inputs and outputs, we're talking about for inputs, x values or domains. When we're talking about outputs, we're talking about y values or ranges. These are all basically synonymous. Input, x value and domain, and then output, y value and ranges. Now, there are several different types of representations for functions. So in this example, you see graphs, you see tables, you see mapping diagrams, you see coordinates, and the goal for each one is we're trying to check if every x value, every input, has only one output listed. If there's more than one, it's not a function. So let's take a look at the first example. For the first one, we have basically coordinates listed, but as a table. So for the x value of 1, we have -1 as the output. For 2, you get 0. For 3, you get 5. And for 4, you get -1. Now, for each one of these, every x value only has one y value as an answer. You'll notice that the x value doesn't even repeat. So it's not like they go over the same x value twice. If, for example, they put 2 again as an x value and it had something other than 0 listed, maybe it had 3 listed as its y value, this would not be a function because 2 is repeated twice with 2 different y values that it matches up to. But in this case, each x value was only listed once. So according to the information that we have, yes, this is a function. Every x value only has one y value that matches up to it. Let's take a look at the second example. Our x values are 2, 5, 7, and 9. And then it's showing you what it matches up with or what outputs it produces when your input is 2, 5, 7, or 9. Now, for the first value of x, the 2, we only have a 4 as an output. But for our value of 5, notice that we have 2 outputs. We have a 0 and we have a 4. I'm sorry, not a 4, an 8. So that means that if I put 5 into my function, I don't know if I'm going to get a 0 as an answer or an 8 as an answer. So there's more than one output, more than one y value for this single x value. I can't have that. When you have more than one line coming off of the x value, it's not going to be a function. So this is a no, not a function. Now in the last example, we have coordinates listed. Let's look at our x coordinates to see if any of them even repeat. We have a -4, -1, 0, and 5. Each x value is only listed once, so there's no opportunity for the x value to have more than one output. So according to this, -4, you're always going to get a 2. -1, you're always going to spit out a -7. A 0 is going to have a 5 as an output. A 5 is going to have a 2 as an output. If I were to have maybe 5 listed again, but give it another output other than the 2, so let's say it would have an output of, let's say 3. Then this would not be a function because we have 5 repeated twice with 2 different y values going along with it. But that's not the case. We only have one x value listed for each one of the numbers. So that means yes, this is a function. Let's keep going. Okay? So now we have two graphs. When you have a graph, you don't have to just start writing down all of the coordinates that are part of the picture on the graph. Instead, you could use what's called the vertical line test. So we're about to use something called the vertical line test. It looks like the letter A has a little eyebrow above it, but that's fine. Okay, so the vertical line test is only used when you have a graph. And the vertical line test is used to see, does your vertical line pass through the picture more than once? If that's the case, it's not a function. So, for example, I'm going to use my highlighter. I'm going to start drawing a vertical line here. When I drew this yellow vertical line, I only cut through the picture once at this point. And that's okay. But if I drew a vertical line anywhere else, let's say for example here, notice that I cut through the diagram or the picture twice. I have a point here where I'm cutting through and a point here that I'm cutting through. I can't have that. You don't want your vertical line to pass through more than once. So this is not a function because my vertical line, the second one, passed through 2 points. So no, not a function. Let's look at the next one. Again, it's a diagram on a graph. So I'm going to go ahead and do my vertical line test. So let's say I start here. Right now, according to the way that it's pictured, I haven't passed through the diagram at all. However, if I were to continue this parabola, according to the arrows, it does continue forever along this kind of diagonal. I would eventually cut through that yellow line, but I would only cut through it once, right around here. So that's okay. Let's do another yellow line. Let's do another yellow line. And let's just keep going. Each one of these yellow lines, I only cut through the diagram once. And that's okay. This does pass the vertical line test. So I'm going to say yes, this is a function because every vertical line I drew only cut through the diagram once. It can cut through 0 or it could cut through once. But if it cuts through more than once, it is not a function. Okay, last one. We have another mapping diagram. So let's take a look at the x values. -4, -1, 0, and 5. Notice that there's only one line coming off of each of these x values. One line here, only one line here, one line, one line. So that means every x value that's listed only has one y value as an answer. That is what we want. So I'm going to say yes, this is a function. Now you may notice -4 and 5 goes to -7. That's okay. You can have different x values go to the same y value. Y values can repeat. You don't want your x values to go to more than one y value. So this is okay. Let's move on to number 12. Number 12. Solve the equation below. Okay, so what we're doing is we're solving for the single variable. Now, if we look across the entire long equation, there's only x's. Now, this may look extremely intimidating at first, but this is just a practice in making sure that you stay organized, that you're distributing properly, that you're not forgetting about any negatives or any positives, and that you're combining like terms correctly. So this is a nice long problem that just makes sure that you've practiced all of those skills. But in essence, this is not a hard problem. So let's start. Now, I'm basically dividing this problem into two parts. Write down the equal sign. So let's take a look at the left. We have lots of coefficients to the parentheses. In none of the parentheses, if I look across my different parentheses, can I do anything to combine within the parentheses? All of those are pretty much simplified. So I'm going to erase all of this highlight. And instead, I'm going to focus on the coefficients, the numbers outside of the parentheses. So for the first set of parentheses, I have a 5 that I'm going to distribute to both terms. Then I have a +7, a -4. Be careful with the negatives. On the other side, I have a -8, a regular old negative outside the parentheses, which is the tricky part. A lot of people forget about that old negative just sitting outside. And those are the ones that I'm going to have to take care of as my first step. So I'm going to make sure I distribute all of these terms. So let's go ahead. Starting with the 5. 5 to x is 5x. 5 times negative 3, negative 15. Positive 7 times 2, positive 14. Positive 7 times negative x, negative 7x. Negative 4 times 2x, negative 8x. Negative 4 times positive 7, negative 28. Then I have the negative 3x and the plus 2, which I don't do anything with yet. Just going to bring them down. Equals. Okay, now on the right side, do the same thing. I have an 11 that I don't want to forget about. And now I'm going to distribute the negative 8. Negative 8 times x is negative 8x. Negative 8 times negative 7 is a positive 56. Then I have a plus 4x that I'm just going to bring down. And now the negative needs to be distributed to both terms. So that just changes the sign of the numbers inside of the parentheses. So negative 6 and a positive 5x if I change the sign of both. Then I have a plus 8 and a minus 2x. Okay, so let's treat both sides separately. Both sides of the equal sign are going to be treated separately. We want to simplify now because we have a lot of x terms and a lot of whole numbers that we can now combine. So let's start on the left-hand side. Let's grab all of the x values. We have 5, 5x, negative 7x, negative 8x, negative 3x. Okay, so I have 5. I have minus 7. I have a minus 8. And I have a minus 3. Okay, so if I do 5 minus 7, I'm going to get negative 2. If I do negative 8 minus 3, I get negative 11. Negative 2 minus 11 is negative 13. So it's negative 13x when I combine all those coefficients. Now we have negative 15, positive 14, negative 28, and a positive 2. All right, so let's get started. Negative 15 plus 14. Let's start there. Negative 15 plus 14. I'm just going to write it over here just for a little bit of room. Negative 15, positive 14, minus 28, plus 2. Here, negative 15 plus 14 is negative 1. Then we have negative 28 plus 2. I'm going to have negative 26. And now lastly, negative 1 minus 26 is negative 27. So it's negative 13x minus 27 equals. Let's see what we have on the right-hand side. Subtract or delete this. Okay. So on the right-hand side, starting with the x's, negative 8x plus 4x plus 5 minus 2. So negative 8 plus 4 plus 5 minus 2. Negative 8 plus 4 gives me negative 4. Positive 5 minus 2 is positive 3. Negative 4 plus 3 is a minus 1. So I'm just going to write minus x. I don't have to write the 1 in front. And now let's look at the whole numbers. we have 11, 56, minus 6, plus 8. So 11, 56, minus 6, plus 8. 11 plus 56 is 67. If you need to work this out on the side and pause the video, go ahead and do that. Negative 6 plus 8 is a positive 2. 67 plus 2 is 69. So we have negative x plus 69. Now, I'm going to go ahead and simplify this a step further. So I'm going to use a little bit more room, and I'm going to rewrite this. Negative 13x minus 27 is on the left. Negative x plus 69 is on the right. Okay, so I want to get all the x's to one side. Technically, negative x is larger than negative 13x because negative 13 is way more negative than negative x. You'd rather have negative $1 in your bank account than negative $13 in your bank account. So negative x is technically the larger value. So what I'm going to do is I'm going to add 13x to both sides to get it over to where the larger x value is. So we have negative 27 equals negative x plus 13 is 12x positive plus 69. And now the last step is I'm going to subtract I'm going to subtract 69 from both sides so that I can isolate. Give myself a little bit more room. So I can isolate my variable. They cancel on the right. Negative 27 minus 69. I'm getting even more negative, so I'm definitely going to have a negative number. And now I'm going to combine 27 and 69. And I'm going to get 96 equals 12x. Last step, I want to go ahead and get x by itself, so I'm going to divide both sides by what x is holding on to, which is that 12. So I'm going to divide both sides by 12 so I can get x by itself. My answer is going to be negative because a negative divided by a positive is a negative. So x will equal a negative number. 96 divided by 12 is going to give you 8, negative 8. So my answer here is x equals negative 8 if I rewrite it. X equals negative 8. So that was a lot of work to get to this final answer. Just make sure that you pay attention to all of the signs. Make sure you're distributing to both terms inside of the parentheses, and take it step by step when combining the like terms. Okay? Long problem, but really not that hard. It's just making sure that you practice keeping yourself organized and distributing appropriately. All right, let's go on to 13, but I'm going to clear off my board. Okay, number 13. Zoom in. In the problem below, which line contains an error? Okay, so there is going to be a problem here. This is not correctly solved. One of these lines has an error in the solution process. Okay, let's look at line 1. 6x minus 2 parentheses x minus 5 equals 22. Well, that's just going to be given to you. That's our starting equation. You can't have an error in your starting equation. So that's just going to be given to you. So that's going to be fine. Now the next step. Well, let's think about what we would have to do in line 1 in order to get to line 2. So in line 1, we have parentheses with a -2 outside of it. What we've been practicing this whole time is distributing the -2 to both terms. So I would get 6x, which is good, minus 2 times x is -2x, that's good, and then minus 2 times -5. Well, -2 and a -5 should give you a positive 10. Instead, here they have a -10. So the first thing I'm going to say is, well, this is a problem. That should be positive, and it's not. So there was an error here in distribution, a very common error. So I'm going to say right now, this is going to be the line with the problem. But let's keep going. Let's say there was no problem. Let's just try and see if the rest of the problem is done correctly. Okay, now, for the next step in the problem, I would combine my like terms. 6x and minus 2x should get combined. 6 minus 2 is 4x. That's good. Then the -10 is just brought along for the ride. And then the 22, nothing was changed there. So line 3 is good. Okay, we were combining like terms. We were simplifying. In line 4, all of a sudden the -10 disappears. How does that disappear? Well, you would add 10 to both sides. Addition property of equality. You'd add 10 to both sides. Addition property. And I would say property of equality. POE. Property of equality. So addition property of equality gets you from line 3 to line 4. Because 22 plus 10 is 32. So line 4 is good. And then lastly, to get from line 4 to line 5, where it just says x equals, I would have to divide both sides by 4. In other words, I would have to use the division property of equality. Division PO. Division property of equality. PO. So 32 divided by 4 gives me 8. I like it. That works. So the only thing that had an error was line 2. The distributive property was not used correctly. -2 times -5 should not have given me a -10. It should have been a positive 10. So my answer is line 2. Okay, let's move on. Okay, number 14. The steps for solving an equation are shown below. Identify which property was used for each step. So identify which property was used for each step. So we have to make sure we know our properties and we know our vocabulary. We have the addition property of equality, subtraction property of equality, division property of equality, and then distributive property of equality. So it tells you what you're doing. Addition, subtraction, division, and then distribution. So there should be some parentheses there. Okay, it's pretty simple. Let's take a look. First thing they give you, 2 times 5x minus 7 equals 2x plus 10. Okay, so that's given to you. That's not going to require any property. Now let's take a look at the next step. So we have 10x and minus 14 on the left instead of having parentheses. Now what would have happened? Well, you would have distributed 2 to the 5x and gotten 10x. 2 times -7 is -14. So they had to have distributed in order to get to the second line here. So if we distributed to get from line 1 to line 2, that means we use the D distributive property. Okay, now let's take a look at the next step. Notice that we're now subtracting 2x from both sides. Okay, so if we're subtracting 2x from both sides, we're using the subtraction property of equality. It's called the property of equality because what you do to one side, you do to the other. So we're going to say B, subtraction property of equality. The equation is remaining balanced, subtracting 2x from both sides. Okay, so 10x minus 2x gives you 8x. That's good. Then we brought down the -14. And then we brought down the 10 that was left over because the 2x's cancel. All right, next step. Now we're adding 14 to both sides. So if we're adding 14 to both sides, we're using the addition property of equality. So using the addition property of equality, the -14, the +14 will cancel. So all you're left with is 8x. And then 10 plus 24 gets you to 24. Last step to get x by itself, we're dividing both sides by 8. Since we're dividing on both sides, we're using the division property of equality, which is choice C. And we get x equals 3. 24 divided by 8 is 3. Okay, so D, B, A, C. That completes page 2. Let's move on to the next video, which will go over page 3.